Hello po sa ating lahat. Good afternoon and welcome po ulit sa ating Thursday Delight webinar. So for today po, may speaker po tayo from Davao Light and Power Company. So siguro hindi ko na po patatagalin pa ito. At let's start and let me introduce our speaker for today. So our speaker for today is a seasoned professional electrical engineer. He's an ASEAN engineer and ASEAN chartered professional engineer with over 20 years of experience in substation projects. Currently, he leads power system protection, instrumentation, and control at Davao Light and Power Company, overseeing the testing and commissioning of conventional and advanced digital substations, as well as high to medium voltage projects. A career highlight includes leading the 242 megawatt power barge system protection rehabilitation project for Thermomobile Incorporated from inception to completion. So he specialized in power system protection and coordination studies, setting protective relaying parameters for power generation, transmission, distribution, and industrial system. As a protection specialist, he supports Aboiti's power sectors with protective relaying consultancy, leveraging extensive local and international training. He also serves as vice chairman of the PEC-1 IEC National Committee and convener of the Technical Working Group on Overcurrent Protection, aligning PEC-1 Article 2.40 with the IEC 6036443 standards. Additionally, he is the National Treasurer of United Professional Electrical Engineers of the Philippines and has served as an adjunct lecturer of Meralco Power Academy. So everyone, let's all welcome po Engineer Jonathan Medalla. Good afternoon, sir. Welcome po ulit sa ating Thursday Delight webinar.
Yeah, good afternoon po. Thank you to our dynamic MC, Engineer San Juan,
Good afternoon, sir.
for the warm introduction. Good afternoon. And heartfelt thanks to everyone joining this afternoon for the Thursday Delight pre-webinar. So this event has been exclusively organized, yung Thursday Delight natin by the IIEE Northern Laguna chapter as part of our continuing professional development program for our fellow electrical practitioners. So napakagaling talaga ng programa ng IIEE Northern Laguna chapter. So it's both an honor and privilege to share my insights on the topic interconnection protection for distributed generation and renewable energy. So without further ado, let's begin. I'd like to let me share my presentation. So I'd like to start my presentation with this video.
We depend on electricity every day, and we rely on our local electric companies to make sure it's there whenever and wherever we need it. To do that, electric companies use a diverse mix of domestic energy resources to make electricity. These include coal, natural gas, nuclear energy, and renewable sources like wind, hydropower, and solar energy. The mix of resources is different in every state and region, depending on what's most available and most affordable. Solar energy plays a growing and important role in our nation's energy mix. And electric companies are leading the solar charge by having built or financed most of the solar power generation we have today. Some homes and businesses across the country are also installing rooftop or private solar panels that convert sunlight into electricity. The sun doesn't shine all the time, and private solar panels can't operate 24/7. So most private solar customers also buy power from their electric company to balance their energy needs. At times when the panels produce more power than the customers can use, they sell what's extra back to their electric company. Whether they are buying or selling electricity, private solar customers still use the energy grid. What's the energy grid? It's the critical part of the energy system we rely on but don't always see, the complex network that makes electricity as reliable as flipping a switch. A strong, reliable energy grid keeps the power on for everyone, both private solar and non-solar customers alike. This is a big investment, and since everyone uses the energy grid, everyone should share in the costs of operating and enhancing it. Right now, an outdated policy called net energy metering is shifting the costs of maintaining the grid. That's because private solar customers who use the energy grid to buy and to sell electricity actually contribute less to cover grid costs than other customers. Yet these customers continue to be connected to the energy grid and rely on its services just like everyone else. Net metering started when solar technology wasn't as advanced and people needed incentives to give it a try. But now these policies need to be updated to keep pace with today's technology. We're all connected to the energy grid around the clock. We all rely on it for electricity. Updating net metering policies is the best way to make sure that everyone who uses the energy grid is paying for it. That's only fair and will pave the way for solar to continue to shine.
Okay, so nowadays, countries around the world, including Philippines, are increasingly adopting various types of renewable energy, such as solar PVs, wind turbines, hydro plants, and etc. Due to their significant environmental benefits, particularly in addressing the climate change, and as well as their advantages in reducing energy costs for electricity consumers. So these power sources are considered distributed generation or alternative energy sources such as renewable energy. So as you can see on the video, even the consumers can be resources of power generation through their solar PVs, in which all day they are operating in parallel and 24/7 connected to our distribution system. But the crucial question, what are the pros and cons or impact of distributed generation and renewable energy to our distribution system? And also, its consequences to us as electrical practitioners, especially to those distribution engineers sa mga cooperative, no? Then private utilities, power system protection engineers, consultants, and other practitioners who directly involved with this technology trend, and most especially to our consumers. Okay, so technically, distributed generation or DG has several known effects such as short circuit level increase due to multiple of energy sources connected to distribution system, contributing to fault current. Okay, so line losses decrease because DG generates power closer to the loads, thereby reducing line current. Okay, and then voltage profiles change as DG can provide reactive power support, improving voltage levels. However, voltage transient may occur if an induction generator disconnect from the grid, as the excitation comes from the external pull-up capacitors. Okay, and then also power quality and reliability can be affected during islanding due to mismatch between the generation and the load. So in island mode, distributed generation may cause over voltage, over frequency, if the generation exceeds the load. Okay, and on the other hand, under voltage, or under frequency if the generation is insufficient. So those impact to the power quality. Okay. And then most importantly, network protections may not function properly because due to the configuration of interconnection transformers, so which will be discussed in detail later. Okay. So therefore, of interconnection protection for distributed generation and renewable energy is crucial. So, and will be the focus on our discussion. So my fellow electrical listeners, distinguished guests, a pleasant afternoon. Okay. So from my extensive experience in power system protection, I believe that protection engineers, distribution engineers, consultants, and other electrical practitioners must thoroughly understand the interconnection protection and transformer behavior, no? Interconnection transformer behavior. They should also be knowledgeable about the Philippine Distribution Code, which provides the foundation for protection philosophy and the implementation of interconnection scheme and stage power system. It impacts on all areas such as generation, transmission system. So as practitioner, we need to optimize the protection settings purposely to achieve the maximum selectivity, maximum sensitivity, maximum speed, maximum reliability of protection settings that even the smallest fault in your system, your protection must detect and protect. Okay? So let's begin our discussion with the electricity sectors in the Philippines, which is divided into three key areas. Okay? First is the generation. Okay? These sectors, we all know that it involves the production of electricity using various energy sources. So it generates the state-owned entities like the National Power Corporation, the IPPs or independent power producers, and private companies like Aboitiz Power, San Miguel, and etc. Okay. So these energy sources includes coal, natural gas, oil, geothermal, hydro, wind, and etc. Okay. So second is the transmission. These sectors is responsible for transporting electricity from generation facilities to distribution network. So the National Grid Corporation of the Philippines, or the NGCP, operates the transmission network, which includes the high voltage power lines and substation. And the third one is the distribution system. So this sector involves delivering electricity from transmission system to the end consumers. Okay. So distribution utilities such as electric cooperative, private utilities like Meralco in Luzon, Teco in Visayas, and Davao Light at Mindanao here, no, to manage this process. Okay. So in the recent year, the Philippine the Philippines has been transitioning towards renewable through Republic Act 9513. So the act aims to accelerate the country's shift towards clean and sustainable energy sources, reduce dependence on protection, energy security, and a sustainable future. The National Renewable Energy Board has created a program, no, for 2020 to 2040. So the government has set a target of generating 35% of the country's energy from renewable sources, no? So napaka ano talaga yung programa ng government, no? So and then also by 50%, no, by 2040. So napaka-aggressive, no, ng government to pursue this program. So the question, is it feasible, no, and sustainable? Okay, so this government program creates many opportunities for distributed generation and renewable energy nationwide, and also provides prospect for us as electrical practitioners. However, the question is, are we technically prepared for its impact? Okay? So this is the topic outline. Hopefully, matapos natin to with required time. No? Ano ba yung limit natin dito, moderator? May time, ano ba tayo? So, okay, let's proceed. So, siguro mga 1.5 hour lang siguro ata to. Okay? So, okay, overview on distributed generation. We all know that centralized power generation produces electricity at large plants, no? Like coal, gas, geothermal, hydro, and send it to the consumers over long distances through transmission lines. Okay? So it offers several advantages. It is cost effective, efficiently to manage, no, resources, and aligns well with the existing infrastructure, making it essential for many energy system. Okay, but from a technical perspective, one direction, no, centralizes a grid, then serving to the customer, no, through transmission line. Okay? So with the grid as a primary source. Okay? So this unidirectional power flow simplifies protection requirement. Okay? Allowing the use of non-directional overcurrent protection without the need the voltage element, no, as a polarizing quantity of directional overcurrent protection. Okay? So and also no anti ano natin ngayon sa DJ, yung pinaka main protection, the islanding protect. It requires no anti-islanding protection, and also there's no issue on power quality, no, for consumers when islanding the distribution system, and there's no requirement on coordination of reclosers to DJ kailangan sinasing kasi loss of energy during transmission. Okay? And it is vulnerable to large outage kasi magiging single point of failure na yung mga transmission line. Okay? So, yun yung disadvantage. And fossil fuel plants pollute, no, raising environmental concern. So those for centralized power generation. Okay? And then for while distributed power generation creates electricity close to where it is used, no, it's proximate to the load. Okay, and mainly from renewable sources like solar panels, the wind turbines, no. This approach reduces energy loss during transmission and improves reliability, no, during outage with system like microgrid. Okay, so it's also support environmental sustainability by decreasing dependence on fossil fuels, no, and lowering the carbon emission while flexible and scalable for local needs. Okay. However, initial cost, no, for these technologies like solar panel can be high kasi mag-i-invest tayo, no, to hindi mura yung magse-set up ka ng solar solar panel, no, sa bahay mo. Okay? And managing small power sources can be complex, allowing with challenges related to regulation and infrastructure integration. Okay? So before we proceed, uh, DG generators. So first is the induction generators. So induction generators, typically it's less than 500 PBA, no? Yung mga liliit lang na mga generator. Then start up like a motor with no synchronizing equipment needed. So meaning wala siyang field excitation system. Okay? So it's a less costly and than the synchronous generator because yung synchronous mayroon siyang excitation system. Okay? So it can provide fault current only a few cycles, no, on the utility system kasi wala siyang excitation system and it don't have no na sustain na voltage, no. It don't have internal voltage that sustain the fault current. So in a few cycles, makaka-contribute siya in sub-transient period, no? So yun yung contribution niya. And then possible self-commutation with the utility pull-top capacitors, no? And can result over voltage kasi yung excitation system niya is coming from external, no? Yung capacitor from pull-top capacitors then to compensate the VAR requirement. Kasi when you are a DG, hindi ka po pwedeng kukuha ng VAR from the system. As much possible, mag-produce ka ng VAR. Okay? While the induction generator has a K-VAR, no? Then it can be compensated by the capacitor. So when it's disconnected, no? Yung induction generator, since mayroong capacitor dyan, it will cause overvoltage in the area. Okay? So mayroong mga ganyang scenario. And then may cause failure resonance, no? As well. Okay? So while the synchronous generator, no, have a field winding to provide source of machine excitation, no? Siya yung magpo-produce ng kVAR. Siya yung while it distributed, no, real power, and then it can support kVAR as well, no, the reactive power. Then for this system, it requires synchronizing equipment. May synchronizing system to monitor, no, the voltage, if they are in phase, no, the voltage, the frequency, and then the angle deviation. Yun yung before synchronizing to the grid. While the induction generator, as long as ma-attain mo lang yung rated speed niya, no, then anytime pwede kang makapag synchronize sa grid. Similar with the asynchronous generator. Okay? But it can provide, no, sustained fault currents to the utility system because it has and then mayroon siyang AVR, no, that can sustain the voltage. Then the next one is the asynchronous generator. Actually, it's a non-traditional, no, small dispersed generators. Internet dito. Okay. So for this asynchronous generator, it's difficult to test, no? And then some utilities do not trust, require other protection. So mahirap tong i-test, no? So like our solar inverters, yun. Kailangan natin i-ensure na mayroon talaga siyang interconnection protection like anti-islanding. Then i-test talaga natin. Okay? And then what are the drivers, no, for the utility? But ini-entertain natin yung DG. because it has a technical advantage. Like it can decrease the losses sa line. It can somehow decongest the transmission line and as well as the distribution. Because talaga namang kung mayroon especially to those far end na ano no end load ng mga customers kasi process of the transmission line distribution, especially yung synchronous generator, since it can support bars, it can improve the voltage no in the system. And then as okay. So okay, so the drivers for utility no but in-entertain natin yung DG despite of disadvantages no, mayroon naman talagang disadvantage siya. Okay, it can somehow decongest the line, improve the power quality in the area no, especially yung malalayong lugar. Then mayroon tayong distributed generation doon, especially yung synchronous generator sa mo makapag ano siya no support siya ng kVAR, improving the system voltage no. Then it can decongest the line kasi we all know some of the loads are constant kVA loads no, and where you if if the system voltage no improve, then it can decongest the transmission line. And then and somehow yung requirement ng power no, we all know that the losses is I squared R no, so it's reduced the power requirement from the grid, so that's why it can improve the distribution system no. It can be a grid support no through ancillary services, and then ready for and standby reserve, and then it can be a spinning reserve no. So yun yung drivers or the advantage of having distributed generation in our system, in the utility system no. While for the consumer, it's obviously for the rate incentives no, and then as well as the power security in case kung wala yung utility, then meron kang sariling power. So that's for the obvious no reason for the consumer no na in-entertain natin, but mas ano natin yung DG no, mayroong distributed generation because of this reason. Okay, and then the worst case scenario during islanding no, when you say islanding, yung distribution system madi-disengage siya or ma-isolate siya sa grid. Then we all know that these loads, distribution load, we don't have the assurance no na magmamatch yung generation or the distributed generation with the corresponding loads no na ma-island niya. And of course, most of the scenario, mas malaki yung loads compare with the generation no, compare with the distributed generation, because in Philippine distribution code we are limited only to 30% no, if for the micro and the small classification of generation, while for the other large and then the intermediate ano I think 25% if hindi given yung ano, hindi known yung loads no, kasi yung minimum loads ng substation kailangan hindi exceed doon yung distributed generation. If not available, yung projection is 25% of the installed capacity of transformer. So obviously sa Philippines mas malaki yung loads when in an islanding condition, but depende yan kasi hindi naman ngayon yung system ng distribution hindi naman talaga radial yung ano natin na isang feeder serving distribution system no. Along the lines mayroon tayong ini-implement na mga reclosing, so depende yan kung saan nakaposisyon yung distributed generation. So may tendency na mas malaki din yung generation compare with the island and load. Okay? So it creates it complicates the restoration, especially when you have a reclosing reclosers, no? Mayroon ka nag-i-implement ka ng mga reclosers, and we all know that reclosers we invested reclosers sa mga distribution utilities because of improving the performance of the distribution utility, no? Specifically on the SIDI and SIFI, no? Yung performance is being rated the indices, no, performance indices through SIDI and SIFI. So but when you have distributed generation or DG, um madidefeat yung purpose, no, yung reclosing, kasi although there's a coordination with the recloser, but prone to prone to misoperate, no, uh, especially kung hindi talaga nag-collaborate yung DG owner between the distribution utilities or electric cooperative. So it requires synchronizing system when you restore uh, the DG, no? And also uh, it inhibits reclosing as well, no? Kung mayroong wala talagang capability yung DG, it inhibits the reclosing kung walang na-invest na mga anti-islanding protection. Okay? Then there's a power quality issues as mentioned kanina, na when the distributed generation, no, is larger than the load, then there's a possibility on over voltage and over frequency. Why? Because once na mas malaki yung abruptly, no, na disconnect yung system from the grid, yung cases na yan, mas malaki talaga yung distributed generation for that feeder, in which nire-regulate yan ngayon. But if the tendency na mas malaki yung generation supplying to the grid, then parang na na somehow na release mo yung load, no, or there's what we call load rejection, and then in a normal condition, no, that load is being compensated by excitation system, and that excitation system compensate the load, no, the load impedance, no, siya yung nag susupply, and then compensated the load. When it's isolated, yung internal voltage mo ngayon with the generator tataas. That's why tataas yung like, there's a tendency yung magkakos siya ng over voltage, and as well as the over frequency, because when you have a load, yung governor mo, no, i-improve mo yung improve mo yung operate mo yung governor, and then that governor is directly proportional to the frequency and as well as the speed of the generator. When it's deloaded and there's a load rejection, mag-overspeed siya, and then the speed is directly proportional to over frequency. So that's why magkakos siya ng over frequency and then over voltage, no? Somehow mako-compromise yung power quality. That's for the case if the generation is larger than the load. And then on the other hand, no, if the generator is lesser than the load, of course, parang mayroong abrupt loading, no? Parang sasakyan na kung abruptly bibigyan mo siya ng load, at that time mag yung speed niya, no? Magso-slow down siya. And then while the speed is directly proportional to the frequency, then there's an under frequency on that scenario. Okay? And then as well as the under voltage. So there's a power quality issue, no? Because of the mismatch of the generation and the load. Okay? So what's the other what's the other risk, no, on distributed generation? So DG provides sources of redistribution of fault current, no, on the feeder circuit, and which can cause loss of relay coordination and potential overvoltage. Anong scenario ba yan? Of course, some of the DG is connected through interconnection transformer. And then yung interconnection transformer mo, nagmamatter yung grounding system, no? Especially if the primary is grounded, no? And then delta secondary, your interconnection transformer will act as a grounding transformer. Okay? And it will, kung titingnan natin yan in the sequence network, nagpaparallel ngayon yung grid mo because the grid or the distribution system is normally grounded, solidly grounded through the substation. Okay? And then when the distributed generator, no, generation is connected to distribution system, grounded at primary side and delta and secondary side, kung ita-translate natin yan with the impedance diagram, the zero sequence impedance diagram, nagpaparallel ngayon yung transformer ng distributed generator and then the substation. Then during line to ground fault, there's a redistribution, no? The sharing of fault current, no? Sharing of fault current between the DG and then the generator. So it compromises coordination. Why? Because yung substation, no, ng utility and cooperative, normally kino-coordinate natin in radial, no, in radial condition, while the DG is connected now, then mayroon ng somehow reducing the fault current in the substation, no, and compromises the sensitivity, and potentially, no, it will cause miscoordination. So that's for another case of having that distributed generation. And the potential overvoltage. Kailan ba yung overvoltage na mangyari? The overvoltage will occur if your distributed generator, no, interconnection transformer is an ungrounded system. And it will happen when it's disconnected and isolated to distribution system. Then we all know the principle of line to ground fault. In ungrounded system, the healthy phases will lead to overvoltage. I-discuss natin yan later, no? And DG also will result damage to utility equipment because we all know that DG, as mentioned, no, it's a fault contributor as well. Okay, if not properly simulated, no, and then found out na lalaki yung fault level, and then yung protective device mo like the fuse, no, na yung interrupting capacity niya is 10 kA, and then lalaki yung distributed generation natin connected to that line, so tataas yung fault level. Baka during line to ground fault or during fault scenario, baka maano na yung ano mo, no, sasabog na yung mga fuse diyan. Although makapag-protect siya, but maano niya, no, na i-exceed niya yung capacity, no, interrupting capacity with the protective device. So we need to review, no. So in our case, we implemented, no, yung mga induction inductors, no, series inductors to somehow reduce the fault current, no. So yun yung one way of yung mga NGR, no, neutral ground reactor. So may possibility na yun yung magiging solution, no, practical solution while replacing those fuses. Imagine mo lahat ng fuse na papalitan mo. So that's why we need to properly simulate, no, of having that distributed generation. Okay, and also the power quality as mentioned. Okay, and then for distributed generation must be protected from the following condition. Okay, so DG needs to be protected from short circuit, of course, no. If you are the DG, you need to gather data, no, or from the utility, what's the fault level, no, at that connection point. Kasi i-relate mo ngayon yung mga equipment mo with your DG as a source of fault current then to properly specify protective devices. Okay, so and also DG needs to be protected from abnormal operating condition like overexcitation. Okay, So if yung distribution system natin is mataas yung voltahe, there's a tendency for the generator na mag-overexcite siya. Okay? So that's why as a utility or a cooperative, no, kailangan din natin i-meet yung requirement, no? As per Philippine Distribution Code, mayroong nakaano doon for the specific requirement of on the connection point, no? Na hindi ka tataas din yung voltahe mo because it can damage the distributed generation, no, or the generator, and also from overvoltage, somehow related to. Okay? So, and also for the unbalanced current, no? As experience, no? One of my experience, yung sa 242 megawatt at Nabotas, no? Power plant, sa diesel power plant, it's composed or comprises with 42 generators, no? Yung nag-load test kami, and then we have that negative sequence protection or device 46. During load test, palaging nag-a-assert yung negative sequence, no, over current protection because of one of the scenario, no, na ba't siya mag-assert because of the unbalanced current, no. Then hindi lang isa, dalawang generator na tinetest namin, even the other barges, because that power plant, no, or centralized power plant composed of 4 barges. So ganon din yung scenario. Then later we found out that the interconnection voltage, no, napaka unbalanced. Okay? Maybe since it was connected, no, sa sa subtransmission line, and that transmission lines have vertical configuration, baka hindi lang na interpose, no, yung transposition ng lines, then maybe that's the cause, no, because napaka-unbalance yung voltahe that would cause, no, the negative sequence over current always assert, no, when we load test. So in that case, if hindi mo ma-maximize yung capacity ng generator because of that excessive unbalance, there's a negative sequence capability curve din yung generator. Then although you can operate, but not exceeded to the limit of the negative sequence capability of the generator. Okay, that's for the unbalanced current. And the abnormal frequency. So as mentioned kanina, so kailangan i-refer natin yung frequency for mayroong doon, no, sa Philippine Distribution Code, yung frequency variation. So doon natin i-refer yung frequency requirement in the distribution system. And then the shaft torque stress due to automatic reclosing. So this DG, no, and the utility or the distribution system should collaborate each other, no. Mayroon silang coordination. Kailangan i-declare ni utility or the cooperative yung reclosing function or configuration to coordinate the protection, no, in the DG side. So hindi po pwedeng diretso na magre-reclose si distribution system, no, from distribution side without coordination, without ensuring that DG is isolated. So may mga requirements yan, i-discuss natin later. So yun yung mga interest ni distributed generation. Okay? So the major impact of interconnection transformer. So by definition, interconnection transformer are used to interface a distribution generation unit with an existing power system or the utility, no, to provide necessary isolation. From the word isolation, there's really an isolation, no, between the low voltage side and the high side, in which the low voltage side is the DG, no, or the distributed generation. Okay? So as per IEEE 1547, no, in which ito din yung ginamit ng Philippine Distribution Code natin, no, the grounding scheme of the DG interconnection shall not cause overvoltage. Okay? So I'm sure mayroon na kayong idea because na-mention ko na yan kanina then that exceed the rating of the equipment connected to the area electric power system and shall not disrupt the coordination of the ground fault protection on the area of electricity system. Okay? So, yun yung ano niya. Okay? Although, we cannot avoid no na mayroon talagang overvoltage na mangyari and then mayroon talagang redistribution of fault current na mangyari, but we need to ensure the proper coordination of your protection as well as the speed, the sensitivity na talagang ma-isolate ka agad yung system mo at that scenario, no? Yung overvoltage at saka yung redistribution or the coordination. We need to ensure and simulate properly yung fault contribution, no? Ng distributed generation versus the distribution utility. Okay? So, okay. In an ungrounded primary transformer winding, no, as mentioned, overvoltage may cause the DG when ungrounded primary windings are applied, no? So no ground sources and DG backspeed once utility disconnected. Okay? So let's review no the sequence interconnection no the sequence connection ng transformer natin no. So what are the ungrounded system? Of course, it's a delta no and ungrounded Y. So and then most of the frequent no na ginagamit natin na transformers yung delta Y grounded primary. Okay? Y grounded system no. It's either primary or a secondary no or low voltage or the high voltage side. So yun yung usually na ginagamit natin for ungrounded no. And then we all know at zero sequence connection putol yung system no na yung kung titingnan natin yan sa zero sequence network yung transformer impedance mo is naka-isolate from the utility. Okay? So wala talagang zero sequence current dyan kasi putol siya. Okay? That's the advantage of that ungrounded system. But the problem, no, mayroon siyang tinatawag na voltage rise phenomenon. So ano ba 'yon, no? Voltage rise phenomenon. Those unfaulted phases, for example, the fault is in the phase A and what are the phases no na unfaulted no during line to ground? Of course, the B and C. So through this symmetrical component no phase quantity as a function of symmetrical component during line to ground fault. Ito yung formula by derivation no mayroong influence yung zero sequence impedance and then the positive sequence impedance. Okay? So from this formula, ito na yung resulting formula no sa phase B. Okay, andito. If the ratio of the zero sequence reactance or the impedance no over the positive sequence impedance is equal to -2, okay? So magiging 0 na ngayon yung denominator mo. And then there's a tendency because we all know that any variables divided by 0 magiging infinite siya. So at this graph, no? This graph, nagiging -2 siya, infinite yung overvoltage niya. Okay? Yun yung pinaka-worst. But there's really a tendency no na mag-overvoltage talaga at certain ratio. Okay? So and by rule of thumb, no? Rule of thumb, parang nagsi-shift yan, no? From phase A fault shifted to ground yung A, then this magnitude ito, that's square root of 3. Kaya mostly 173% or yung phase voltage mo is magiging line voltage na ngayon because we all know that the formula no for the line voltage is square root of 3 with respect to the phase voltage. Okay, that's the worst. But as mentioned, ang worst case if found out, no, na yung zero sequence, the ratio of zero sequence impedance over the positive sequence impedance will be equal to -2 infinite yan, no? So, yun yung pinaka parang ferroresonance effect niya. Okay? And then, what would be the appropriate protection? Because there's no zero sequence current, no? On that time, no? So, kung magkaka-fault dito, okay? Since this is delta, no circulation, no, of zero sequence current, no, for this scenario. So, yung overcurrent protection mga yon is not effective anymore. Okay? For the appropriate protection for that is the 3VO, no? So, which monitoring, no, which monitors the voltages, no, the phases, and then vectorial sum of that, yun yung magiging sensitivity mo. Okay? Yun yung mga quantities na titingnan mo, no? The zero sequence voltage protection or the 3VO. Okay? That's for the ungrounded system protection. Okay? So let's simulate the ungrounded primary interconnection transformer, no? Ano ba yung magiging scenario? Okay? So this transformer is the substation transformer, no? Distribution substation transformer. Okay? And it has 4 feeders, then in which the distributed generator, no, is being connected to breaker A. Okay? That's the scheme. Okay? And then when there's if your interconnection transformer, no, is delta delta, okay, ungrounded siya, and then Y grounded delta, still ungrounded yung primary, and then delta Y ungrounded primary. So those are the ungrounded primary interconnection, no? And then the advantage, no, of having this ungrounded system, so when there's a fault at F1, no, since we all know that there's no zero sequence current, wala siyang backfeed, no, for zero sequence current. So yun yung advantage niya. Okay? And then also, if there's a fault at F2, no, line to ground fault, so wala kang circulation, no? Wala kang contribution from the DG going to this fault F2, in which hindi mo na ngayon i-consider for coordination, no? If grounded ito, you need to consider the fault contribution from the DG and then from the grid, and then you need to consider yung fault contribution, no? Magkaiba yung fault current contribution from the grid and from the DG, then magiging complex yung protection coordination mo ngayon. Okay? So that's the case for the grounded system. But in this case, since it's ungrounded, so we can consider, no, na walang zero sequence current on that type of configuration. Then no ground current from breaker A for a fault at F3. Okay? So kung may fault dito, since it's ungrounded, no, isolation, so yung coordination mo ngayon at the load sides is hanggang dito lang. Okay? So you need not to coordinate, no, yung fault, yung protective device dito to the primary, no, protection, high side breaker, or to the substation. So yun yung advantage niya. But the disadvantage, okay, can supply feeder circuit from ungrounded source after substation breaker A trips, no? Kung magti-trip ito. Okay? And then this is a sustained fault, no? Since it's ungrounded, yung healthy phases mag-shift into overvoltage. Okay? So that's the problem. Okay? Mag-overvoltage yung line. And then okay lang yung mga three-phase na transformer or shift them kasi mag-shift lang yung reference. But the problem, since we have this single transformer, no, full tap transformer in single phase connection, so yung those full tap transformer connected to healthy phases, no, magkakause siya ng overvoltage, no? Up to 173 or magiging phase voltage siya. So in result, ma-overexcite yung transformer mo, no? Iinit yung transformer mo. Sisira yung transformer mo. Masasaturate yung transformer mo. That's the case, no? For a line to ground fault, sustained line to ground fault, no? Na na-island ng DG. But many utilities, no? Allows this ungrounded, especially if yung load, no, if known yung load niya 200%, no, during islanding, because that 200% will compensate the overvoltage. So tinotolerate lang yan, no, ng iba, but it's not our practice, no, dito sa Pilipinas. Mayroon talaga tayong anti-islanding protection, okay? So the overload prevents overvoltage from occurring. And also, those power cables, no, na ginagamit natin at the distribution side or the high voltage side, may expose siya from overvoltage. Especially if your power cable, no, 100% yung insulation niya, no. So, but it can sustain, it can operate up to 1 minute. So, if your protection, no, will trip, no, and less than 1 minute, somehow ma-protection na yung 100% insulation. But the worst case, if you are the designer, if your system is ungrounded, you need to consider to improve, no, the insulation level up to maybe 133%, or the safest one is 173%. Okay, so that's for the design consideration for ungrounded system. And what about, no, the grounded primary transformer winding? What's the impact? Okay, so sabi dito, ground fault current contribution caused by DG, no, grounded primary transformer windings during utility faults. Okay, and then source feeder relaying and reclosing responding to secondary ground within the DG facility. So actually, my experience, no, mayroong isang distributed generation, then although during tripping, no, of that recloser, no, dedicated recloser at their end, kasi mayroon silang sa connection point, the distribution utility requires them to have that recloser. Okay, then they have Y grounded primary, delta secondary, no, and then the distributed the and it has synchronous generator at that time. But nang nagka-fault, no, single line to ground fault, yung distribution line which the DG is being connected, nag-trip sila, no, nag-participate sila. So palaging nag-minis-operate. Okay? So ni-review namin ngayon yung case. Although it's known na hindi pa gawa, no? Hindi ongoing pa yung construction ng generator, but the interconnection transformer is already energized, no, para sa temporary power facility nila. So nagtaka sila, ba't palaging nag-trip? Yung fault naman wala naman sa labas, wala naman sa loob, kundi yung fault is sa labas. Nagpa-participate yung recloser nila, nagti-trip. So that's why hindi pa namin alam, no, na grounded yung primary, but when we download the events, prominent yung zero sequence current, no, doon. And then mayroon na kaming hinala na I think grounded yung primary niyan. And then even without the generator, no, as mentioned, that interconnection transformer, no, the Y grounded primary delta secondary will act as a grounding transformer, no. So nagsi-share sila ngayon ng fault current with the substation. So need natin na i-coordinate yung fault current contribution, no. We need to simulate what will be the fault contribution of that interconnection transformer with respect to the the substation or the distribution system para mauna yung feeder bago sila mag-trip or hindi sila mag-trip or maybe ano siya tawag nito i-disable yung protection, okay, but that's the case, no, that's for the grounded primary because of this zero sequence connection na diretso siya. Okay? So, mayroong yung DG interconnection transformer mo is in series na with the distribution utilities. Okay? So, let's simulate the grounded primary interconnection transformer. So, with the same model, no? Ang nagkaiba lang dito is grounded na yung primary, okay? It's Y grounded primary delta secondary, Y grounded primary, Y grounded secondary, okay? So for the Y grounded primary delta secondary, ano ba yung advantage niya? Hindi naman pwedeng puro tayo disadvantage, no? Discourage natin yung Y grounded primary, okay? So the advantage, no ground current, no? From the breaker A for false F3. So the same, hindi mo na kailangan i-coordinate yung protection mo sa secondary side ng DG to the primary because it's isolated, no? Alam naman natin yung zero sequence network niya, putol siya. Okay? And then also, if there's a fault on this distribution line for that feeder A, no? No overvoltage. Okay? Because we all know that the grounded system, yung mag-change with the behavior, no? I mean, kung faulted yung A in a grounded system, siya lang yung magtataas yung fault current, no? Magdidip yung voltahe, but the other phases remains constant, no? Or healthy. So, yun yung characteristic niya. Then, no overvoltage, no? On that scenario. Okay? And also, the disadvantage provides an unwanted ground current for supply if F2, no, at fault at F2 and F1. So, meaning, pag magka-fault dito, yung adjacent feeder mo, so yung coordination mo ngayon, it's a sum of the fault contribution from the grid and also the contribution from the DG. So, ngayon, instead of in a radial system, no, in which nung una, yung centralized pa, hindi pa natin entertain yung distributed generation in the line, yung coordination natin is from the high side, no, the main of the substation breaker, then coordinated with the feeders. So ngayon, i-consider mo na ngayon yung fault contribution from the DG and also the fault contribution, no, from the grid. So medyo complex na ngayon yung system. Or else you will implement directional, no? Directional relay to address to simplify the coordination. Yun yung ano niyan. But the problem, kailangan natin yung kailangan mag-invest ni DG, no, as the distribution owner, no, or we are responsible especially to those distribution engineers, tayo yung in charge, no, on protecting our system. I-require natin yung DG to invest for that protection, yung directional, kasi mayroon siyang impact, no. Kung hindi natin i-address yan, possible na magkakos siya ng miscoordination, no? Impacting those customer, no? At this line. So, mayroon na kayong widespread na brownout or blackout. So, those are the problem with the grounded primary. Okay? And so, allow sources feeders laying A to respond secondary fault at F3, no? For the YY, since it's in series, no? Yung nakita natin sa zero sequence connection kanina, the interconnection transformer impedance is in series with the distribution system. So if there's a fault at the secondary, kailangan natin i-coordinate, no? Yung sa high side ng mga protective device, including the feeders. So kung wala mang mga reclosers along that line. Okay? So, yun yung kailangan natin i-familiarize yung behavior ng system natin when we entertain distributed generation. So, another case, no? If the fault is near at the end of the feeder, the reduction of substation ground fault current may result in substation ground fault relay not responding to fault. Okay? And if this the case, the utility have to add pull-top recloser to detect ground faults near the end of the feeder. So, ang ibig sabihin nito, if there's a fault, no, at the end load, sequence impedance, no? Yung at zero sequence network, yung DG transformer and also the DG at the utility substation, there's a sharing of fault current, no? Or redistribution of fault current. Thereby, magiging insensitive na ngayon yung protection mo, no? Yung feeder at breaker A. Kasi there's a reduction of short circuit, no? Because we all know that short circuit, hindi lang siya piniprevent natin, but meron siyang benefit, especially if your protection, no, is overcurrent protection. Because overcurrent protection is dependent on the magnitude, no, of the fault current. The clearing time is dependent on the fault current magnitude. Okay? If you have a lesser fault current, then possible tataas yung clearing time mo. It's inverse, kaya inverse characteristic yung overcurrent natin. So to address that issue, kailangan natin simulate, we will invest, no, a pull-top recloser dito, setting the sensitivity based on the fault contribution, no, ng distributed generation. Okay? So yun yung isang consideration natin, no? If we have that DG, if we perform, no, or conduct a distribution impact study. Okay? So yun yung mga problema na kailangan natin ma-identify. And also, if you are a utility, no, implementing this fuse saving scheme, okay, in a radial condition, no, in a radial scenario, yung sinabi ko, fuse saving is coordination, no, it's a coordination of the protective device fuse and the recloser. So at first trip, no, or first operation ng recloser mo, it will act as instantaneous, na mas mabilis yung recloser mo compare with the fuse if the fault, no, nasa load side ng fuse. Because ang consideration natin ito is the transient fault. Yung mga momentary fault lang. Okay? And also, in the second tripping, no, if it's sustained fault, that's the time na yung fuse mo magpo-blown. Kaya fuse saving scheme. But the problem with this DG, kung nakakonect yung DG dito, so yung simulation natin, no, if hindi na-identify, no, or hindi na-consider ng gumagawa ng study ng yung may fuse saving scheme pala dito, okay? So, madidefeat yung purpose ng fuse saving scheme. So, although it will act as normally kasi mauna yung fuse mo, but yung savings, no? The potential savings natin mawawala kasi fuse saving eh. Okay? So that's another case for having this distributed generation kung may fault yan. Okay? So if the fault on the adjacent F2, no, as mentioned kanina, no, since there's a fault current flow, no, ground fault current flow from the DG, okay, so kung it's a normal non-directional overcurrent lang to, hindi directional, talagang magti-trip din ito, magpa-participate siya. So ito si feeder, si F2, kung may ka-short circuit dyan, if not coordinated yung protection with this feeder A, so it will cause maybe ang pinaka-worst nito, maa-island mo yung distribution system, you know, connected in the feeder A. Okay? So to avoid this situation, An overcurrent feeder relay breaker may have to be directionalized. So kailangan natin i-convert natin siya from non-directional overcurrent into directional overcurrent, no? Because this transformer here, no, act as a grounding transformer, which zero current circulating in a delta secondary winding. Okay? So, yun yung ano niya. Mayroon siyang fault contribution, no? Or redistribution of fault current. So, DJ interconnection protection methods and practices. So, when we when we apply, when we implement protection, we need to consider these principles, no? Again, ito yung always na ini-emphasize ko na you need to have these principles, reliability, meaning it has a dependability, no? And then the security, when you say dependability, kung may fault, talagang magti-trip ka, no? Yung protection mo magti-trip. And then for the security and stability, if the fault is outside of the zone of protection, talagang secured ka. Hindi ka pa-participate ng tripping. That's for reliability perspective. Okay? And then the selectivity, so yung coordination. So as mentioned, yung kanina, if yung adjacent feeder is doon lang yung fault, then the breaker A or feeder A will not participate, no? So to ensure proper coordination, hindi madadama yung customer doon, and then potentially ma-island pa ng DG yung distribution system, yung load na nakakonect doon. And then it has an impact on revenue. Okay? And the sensitivity, it's more on kung nakita natin kanina, there's an issue on sensitivity, especially for the Y-grounded primary interconnection transformer, no, ng DG, because there's a redistribution of fault current which desensitize the protection at the utility substation. So mako-compromise yung sensitivity, no? If hindi makikita ng protection, it also compromises, no, the speed of the protection, because that reduction of fault current will hindi makikita. Then if there's a fault, compromises the stability of the system, no? Mayroong nangyayari diyan na voltage dip, voltage sag, okay? And the speed, no? So you all know that speed has an impact, no, as mentioned, on stability. Sa amin nga yung yung sa thermomobile, no, yung sa nire-require kami ng Meralco about 100 milliseconds, no, once may fault, no, on the transmission line, your protection will clear, no, at 100 milliseconds, no? So ganun kabilis because of the stability issue, and also the equipment damage, and as well as the power quality. Imagine kung naa-island mo ngayon, ikaw yung DG, na-island mo ngayong distribution system, yung load, pag hindi na-isolate, magka-potentially ma-expose mo sila on overvoltage or undervoltage or any power quality issue. So dapat mabilis yung isolation, no, ng DG in an island condition. So protection objectives. For the utility concerns, ang concern ng utility, yung fault contribution, no, ng DG. Ano ba yung magnitude, mag-contribute siya, no, sa system. Then yung na-mention ko kanina, yung fault contribution will cause miscoordination, no, and will cause customer outages. Magka-brownout na tayo, okay? And then yung na-mention kanina, yung mga existing natin na mga protective device dyan, yung mga fuse, mga recloser, mga breaker, baka nag-i-exceed na, no, with the interrupting capability ng mga breakers. So kailangan i-balance din natin yung benefits, no, ng introduce natin ng DG, or any solution na ma-mitigate lang natin, no? Ma-manage lang natin yung scenario. So there's really a need, no, of impact study, distribution. Kaya may distribution impact study tayo because of these potential concerns, no, ng utility. And then the transient overvoltage, no, during islanding, na-mention ko na kanina, if the generation there's a mismatch, no, with between the generation and the load, hindi sila balanse. Okay, and then transformer connection and the ferro resonance, as mentioned kanina, no, there's a tendency during line to ground fault, if the ratio of the series sequence impedance divided by the positive sequence impedance, as tataas siya up to ferro resonance yung ano niya, yung impact niya. Okay? And then also the power quality, no, on the islanding, the voltage and the harmonics. Okay? So yun yung concern ng utility if papasok si DG or mga renewable energy natin sa distribution system. And then unfair naman kung yung i-consider lang natin, no, yung concern ng utility. Titingnan naman natin, no, on the DG perspective, ano naman yung concern nila. So they are concerned on reclosing scenario, or yung ini-implement natin na reclosing, because as mentioned, reclosing save the ano, no, the SIP and SID, improving the performance indices, no, of the utility, because the utility, the cooperative is being rated, no, their performance through SIFI and SID. Then addressing those or improving those ano, through that automatic reclosing. But there's a potential risk, no, for the DG, because if not considered na walang coordination, ang ibig sabihin na if there's a fault, then magre-reclose, then running yung generator mo, no? And then hindi naka-isolate siya, no? Dapat ang coordination, that ensuring that the DG is isolated, no, when you reclose the recloser. So masisira yung mga ano nila, yung generator. And worst case, don't you know na mas mataas yung fault current, no, yung out of synchronism fault. So mayroon yan, mas mataas. So thereby, therefore, magiging there's a potential risk on the breaker, no? Baka sasabog pa yung breaker mo if hindi ano, if nag-i-exceed sa interrupting capacity ng recloser mo. So those are the potential risk. And then transient overvoltage also affect generator. Okay? So because all know that you cannot operate generator at overvoltage, no, na scenario, because of the potential ng overexcitation. Once you operated, no, generator in an overvoltage, masisira din yung iron core ng ano, ng generator. So yun yung concern din nila, no? Kailangan masupplyan din natin ng tamang voltahe yung generator. Yung iba nga hindi makapag-synchronize yung generator if mayroong capacitor bank, no? Tina-turn off pa yung, di-energize pa yung capacitor bank bago mag-synchronize yung generator because of that overvoltage scenario. And then the power quality affects the load served from generator bus. Okay? So as yung kanina, no, as mentioned, one of the case na napaka-unbalance yung system, and then also affects the capacity of the generator, although you can because that unbalanced current, no, as also limits, no, yung negative sequence capability ng generator. So malilimit mo ngayon yung capacity because you need to consider the unbalanced current. Okay, so it's actually a conflicting objectives between the DG owner and then the utility, because maybe yung utility napaka ang tawag nito, napaka-conservative nila, nire-require lahat ng protection, and then it's an investment kasi yung mag-i-invest niyan yung DG owner, no? Any impacts, no, from distribution impact study, it will be converted to distribution asset study, no? Ano ba yung mga requirement addressing those concerns? So kung hindi maintindihan niya ni Gigi, it's a source of conflict actually, no? Kung hindi talaga walang explain in layman's, no, for that requirement for the DG side, no, and also for the utility, no, yung mga sa the utility naman dapat alam din natin, makikita natin yung potential risk ng distributed generation or impact niya, or else baka madadamage yung mga appliances ng mga consumers natin. Okay? So, sino yung babalikan? Hindi naman yung DG. Tayo yung owner diyan. We are the in charge. We are to protect, no, the distribution system. So, i-ensure natin yung impact niya. Yun yung kailangan natin ma-identify. Okay? And the worst case, baka madadamage yung mga equipment natin, no? Napakamahal naman ng equipment natin sa high voltage side. Okay? So, what is the DG protection? So, protection that allows the DG to operate in parallel to utility. So, protection arrangement, usually andyan talaga sa high side, no? Sa utility. And then it's mayroong DG interconnection protection on that interconnection point, no? So this is one of my experience, no. It's sa Therma mo, it's 242 megawatt, no, na power plant comprised with 42 generators, 8 units power barges, no. And then kung nakita natin, there's a tendency na isang transmission line serving those 4 barges. Okay? But ang challenge nito is the speed requirement, no? Yung protection, yung clearing time na requirement with the Meralco na require kami na 100 milliseconds na clearing time when there's a fault, no? At this transmission line. Okay? And then yung kung mag-i-implement tayo ng line differential, so line differential up to maximum of 3 terminals only, no? Okay lang to if in one transmission line serving 2 barges, no? But during that time, hindi pa gawa yung isang transmission line, so we need to operate with a single transmission line. So how can we meet the requirement of 100 or less than 100 milliseconds na clearing time? Okay? So although there's a technology, no? There's a technology ngayon, digitals na mga na matters, but the problem, we do not want our system na magiging guinea pig, no, with the new technology, even hindi pa wala pang implementation, although maybe it's tested and proven with the supplier, but uh, hindi kami pumayag na we are the one, no, the first na mag-implement ng technology. But since we have a consultant as well, no, it's a third party sa US, it's actually the chairman of the rotating machine and transmission line ng Power System Relaying Committee, no, one of our consultant. So they developed, no, the scheme that what we call the semi-directional blocking scheme or pseudo blocking scheme, no. It's actually similar with the, if I'm not sure if you are familiar with the zone selective interlocking, no, na if faulted yung bus, no, it will act as the protection will act as instantaneous, no, or high speed. And then if dumaan ng breaker, or you need to coordinate, no, at the downstream, it will send directional blocking. So there's a connection or a communication between the downstream na breaker to the upstream, no, sending blocking scheme na will act as a time delayed protection, no, or tinatawag namin to na zone 2 blocking scheme, no. So na-meet naman yung requirement. Actually, most of the protection engineer ng Meralco during our end-to-end testing, no, tawag natin na end-to-end testing, ensuring the communication of the transmission line, the the switching station, and then the remote, no, local and remote na properly coordinated talaga, no? Both scenarios, the stability testing and then the dependability testing, no? When you say dependability testing, magti-trip talaga accordingly. So successful naman yung implementation, nagiging selective naman. And then ang point nito, if there's a fault, no, at the bars, since those healthy barges magko-contribute sila ng fault current, then it allows, no, the faulted bars na mag-isolate, then it will not cause cascading sa imagine sa 42 generators, 242 megawatt, na if not properly coordinated magti-trip, talagang may impact yan sa grid, no? It's actually a loss of generation. So ano ba yung impact niyan sa distribution system kung mawalan ka ng source? So meaning mas malaki na ngayon yung load mo compare with the generation, yung impact diyan sa distribution magko-cause ng under frequency. Okay? So that's why baka gagana yung mga automatic load dropping ng Meralco, no? Imagine 242 megawatts. So we need to ensure the selectivity of the protection, no? So that's why ganun yung impact niya. Okay? And then and also we implemented this breaker reclosing scheme, no? Na mayroon siyang voltage supervising synchronism check na ensuring na if the generator, no, or line side, the DG is live and then dead yung system, meaning de-energize yung line, hindi siya magko-close, no, ng breaker because it's simply parang na-interpret natin yan, nai-island niya yung system kasi patay yung linya, then i-close mo pa yung i-close mo pa yung breaker. Something like that, no? Yung parang layman's niya na ano. But you can able to close the breaker if live yung distribution system, utilities, and also dead yung generator, okay? For ready for synchronizing, no? And also can able to close also yung kung synchronized na. If live yung generator, live din yung distribution system, as long as ma-meet yung mga parameters, no, na requirement ng voltahe, ng angle deviation, and as well as the frequency. Okay? So yun yung principle niyan. And then also ensuring sa reclosing, no? Kasi reclosing ito eh. So that's one of the requirement of restoring the distributed generation na ensuring safety yung restoration niya, no? Synchronizing with the system. And also this anti-islanding protection, no? So tinitingnan ngayon yung mga statuses ng mga breaker, no? For example, if this is the DG, no? Yung mga power barges, no? Na tinitingnan if yung mga switching station connected, if open yung mga breakers na yan, no? With this logic, ini-interpret nila, no? I-interpret yan na, oy, it's a loss of connection na, no? Ng mga adjacent na mga breakers na ailan na ako, then magti-trip na ako. So that's the ano. Then there's a transfer tripping, no? Transfer tripping doon na kung mayroong communication, no, between the distribution utilities and then the utility, no, the DG, no, mayroong scheme na ganyan, mag-i-initiate siya ng transfer tripping na ensuring na na-isolate talaga ang DG because if there's a reclosing implementation, ensuring na wala talaga sa ano, no, de-energize talaga or isolated talaga yung distributed generation when we restore power. So that's the scheme, no, na yung ano ng what nire-require natin ng anti-islanding. Baka hindi maintindihan yan ng DG owner, no, na napaka-expensive niya because you need to invest the communication facilities, no, and then as well as the RTUs and so on. Okay. So per standard, these are the protection function usually used for interconnection protection. So we have this under over frequency, no? And then the 27, 20, 59, the over under voltage frequency, no? And then the over voltage instantaneous, and then the transfer tripping, no? It's actually yung objective nito is a detection of loss of parallel operation with the utility. Okay? So ang problem nito, yun nga na-mention ko, one, it's loss of parallel to the utility. Mayroon talagang power quality, no, issues, no, mayroon talagang variation, no, of frequency and the voltage, that there's a limit then, no. Then our protection, uh it's coordinated then, no, with the limits, no, under the Philippine Distribution Code. Kaya yung mga settings natin diyan, as much possible, hindi i-exceed, no, with the tolerable values, no, as mandated, no, as stipulated in the Philippine Distribution Code. So yun yung ano diyan. And then fault backfeed detection, no. So our current natin, if our generator is a synchronous generator, we need to have this 51B. What is 51B? It's a voltage restraint control or voltage control or voltage restraint, no, over current protection, because that's that synchronous, as mentioned, no, sustain yung fault niya, but at 30 cycles in above, mas malaki pa yung full load ng generator with respect to the short circuit current because of that synchronous impedance, no, na synchronous impedance is more than 100%, no, or 1 per unit with the generator impedance, no. So that's why mas mataas yung ano, yung full load, because that full load will be the I base, no, during short circuit calculation. And then how to detect, no, how to protect if the fault sustained up to 30 cycles and above. Kasi if a usual non-directional overcurrent relay yung gagamitin mo dyan, mawawala yung sensitivity because your non-directional overcurrent relay, no, is based on the full load of your generator, not the minimum short circuit at that subtransient at that synchronous state, no. So hindi mo maximize ngayon yung capacity ng generator mo. So that's why for this voltage control or voltage restraint niya, yung sensitivity nito magbabari based on the voltage, no, of the fault voltage. Kasi normal ng voltage is magdi-dip, no, maybe it will reduce 50%. Yung sensitivity mo ngayon mag-i-reduce din. So ma-detect pa rin yung ano, yung short circuit for that worst scenario. Now that's for the fault backfeed detection and so on, no. Marami pang mga protection diyan. And then the damaging condition as mentioned kanina, yung mga negative sequence, out of state, yung mga large generator na to. And then the abnormal power flow detection, no, yung mga reverse power. So yan, depende na yan, no, sa application, but sa US kasi to, yung Rule 21 ng California, no, na mayroon silang reservation on direct reverse direction, no, reverse power flow. So mayroong ganyang application. And then the restoration na kailangan talaga ng synchro check. So those are the basic, no, na protection or protection requirement for interconnection protection. So based on the Philippine Distribution Code, no, mayroong provision dito. The requirement of protection system at connection shall be agreed upon the DU and the end user. So hindi pa pwedeng si DU ito talaga yung requirement namin. Kailangan dito yun kasi mayroon yung impact if yung end user, no, yung DG owner, kailangan mayroon ding counterpart na engineer, no, na knowledgeable na baka over din yung requirement, no. Kung wala namang parang abogado with that for the DG part kasi somehow cost din siya, then kailangan mag-agree, no? Bigyan din ng ano din. It's actually a mutual agreement between the DU and then the DG owner. Okay? So, yun yung parang rule of thumb dyan. It's not the utility lang, no? Kasi hindi naman natin alam kung nasa utility mga engineers that ganyan na reachable. Baka yung iba dyan is ito na yung ginamit sa nung una. Dapat ito na rin ngayon. So it depends, no? It depends. Okay? So the DER shall be designed and operate with the protective device following with the requirements, no, of the DU. So actually the DU has a protection philosophy, no, na-establish na protection philosophy, but the DG side kailangan din mapaliwanagan din sa kanila yung requirements, because imagine if the practicality of requiring anti-islanding protection, no, na magre-require ng communication, then your DG rated at maybe 100 kilowatt, di ba? Baka yung practicality naman, baka mas mahal pa yung facility na nire-require ni DU with respect sa opportunity. Sana, no, na tayo uh, yung interest natin, yung mga consumers, it's more on the rate incentives, no, because of this renewable energy. But if the DU medyo stricto, kailangan mag-invest ka na, kailangan ma-monitor namin yung ano mo na na-isolate ka, something like that, no. So kailangan pag-discussan talaga. And then the fault clearance time shall be within the limit established by DO in accordance with protection philosophy adopted by distribution system, no. So sa Philippine Distribution Code walang na-mention doon na clearing time, but in the grid, no, Philippine in the grid distribution Philippine Grid Code, PGC, yeah. So may naka-ano doon na provision doon na 120 ms voltages less than 138 kV. Kaya sa Meralco nga, yung ni-require sa amin is 100 ms. Okay, so yun yung ano, yun yung compliance kasi because of those impact, no, as mentioned. Kasi kung hindi makiklear kaagad, possible na may expose yung mga consumers with the power quality, no? Yung speed with the islanding, and then the short circuit condition as well, yung coordination, and then yung stability ng system, baka magko-cause ng degradation with the system. That's the impact for the having for clearance time requirement, no? And also na-discuss na natin to, yung reclosing, no, na impact. Dapat the DO shall provide the details of any reclosing. Ito mandated talaga to sa ano. So meaning taga-DO or the cooperatives, no? You must provide the details, no, to the DG po, DG din, and then for them to coordinate their protection, no? Or mag-agree kayo kasi ensuring that when you implement reclosing, the DG is isolated, no? So yun yung message lang dito. And also any design, no, possible disconnection only one phase, single phasing, no. Of course there's an impact, no, as mentioned kanina. Single phasing will cause unbalance sa distribution sa generator, no. So mas worse yan compare with the unbalanced load. Then excessive talaga yung unbalance yan. So you are the in charge with your protection. You should have the negative sequence, no, over current protection coordinated with your damage curve, no, the negative damage curve of the generator. Okay, so it's not the responsibility of the utility, no, or the cooperative kung mag single phase yung line, kasi existing yan dyan. Kung mayroon pa yung mga lateral fuse nag line to ground, may possibility talaga on single phasing. Then you must have appropriate protection for that scenario. So nasabi yan ng distribution code. And then ito na yung embedded generator, no, generation classification. Okay, so in every type of generator, no, because in accordance with the capacity, installed capacity, no, so pag 10 megawatt above, it's a large embedded generating plant. May corresponding siya na protection arrangement. If the large BRA, the same, no, it's 10 megawatt, no, and above, large. And then for the medium, it's in between the 10 megawatt and 1 megawatt. Okay, and for the intermediate, no, still connected to the medium voltage, but yung range niya is 1 megawatt to 100 kilowatt, no? And then for the small, no? And then small embedded generating plant, it's in between the 10 kilowatt and 100 kilowatt, and micro is 10 kilowatt and below. So, but the small and micro uh, at the LV side, no? At the low voltage network. Okay? So, yun yung ano niya. And then there's a provision, no, on protection arrangement with the large conventional generating plant, 10 megawatt and above. But walang specific dito what's really the protection scheme. But ang na-mention lang dito, no, shall be designed, coordinated, tested to achieve the desired level of speed, no? Speed, sensitivity, selectivity, and then also prevent unintended islanding protection. Yun yung lang yung na ano dito. Medyo general siya, but later mayroon ding mga protection scheme doon with the types of the generator. So, yan ang provision, no? And then shall be responsible separately for protection the electrical equipment facilities and their respective side. So, sila yung DU shall be responsible with the distribution utility side, and then the embedded, no, or the DG, sila din yung responsible doon. So any problem, no, or any damage na andoon sa ano, it's a responsibility of both parties, no. And then for the large BRE, the same yung provision, no. Pinakita ko lang actually ano, hindi in detail, but designed, coordinated, tested to achieve the desired level, no, of sensitivity and selectivity, and then respective side. Okay? And then for the medium, no, may na-mention dito na anti-islanding, no? So, selectivity and fault clearing, including anti-islanding, among others, no, minimize impact of distribution, and shall have protection, disconnects, distribution at any event, no? So, any event doon may at your side, ikaw nang bahalang mag-protect. Okay? And responsible system for the electrical facilities and equipment. So walang yung mga provision doon. And then the same, the speed, no? So the same lang yung mga requirement. But for this small and micro, which the low voltage side, kasali dito yung mga solar panels, no? And dito. So ang provision ito responsible for protection of electrical equipment facilities, no? The same with the provision ng mga higher na mga generating plant, but adequate protection for each facility under the operating condition. Na isali dito yung single phasing, no? Na-emphasize talaga. So kung mayroong problema, na damage yung generator nyo, no, sa mga DJ or sa mga tinatawag natin na prosumers. Kasi mga prosumers is yun yung mga they are producing energy at the same time consuming energy from the grid, no? So kung three-phase system yan dyan, mayroong problem na nangyari dyan, it's not the responsibility of distribution utility, no? Anong nangyari sa system nila, uh, but your protection are not limited to single phasing supply, system faults, equipment failure, abnormal voltage, frequency lighting, switching, excessive harmonic voltage, excessive negative sequence, no? As mentioned, and then islanding. Okay? And then automatic synchronization device shall be installed to monitor the control of synchronism. So actually, nare-require pa dito yung ano, no? Mayroon talagang synchronism check, no, or synchronizing system sa side sa LV, no, yung mga micro and small. And then synchronizing settings, no, automatic connection settings shall not be changed following the installation unless agreed with the distribution utility. So hindi basta-basta na mag-change ng settings with the synchronizing system, kasi malaki din yung impact din ng distribution, because imagine you synchronize, you parallel to the distribution system na out of synchronism, no? So kailangan the settings must be within this ano, no? Nandito sa baba, yung 20 degrees, 10% voltage difference and then the frequency deviation, no? So the 0.3. So hindi po pwedeng i-exceed dyan or else magkakaroon ka ng impact with the distribution system. But based on the net metering rules, no? So net metering rules, no? As for RE program pursuant to Section 10 of the RE Act, the net metering program allowed the end user to generate electricity from RE-based system up to 100 kilowatt, no? And then for own use and sell their excess to the grid. So yun yung ano, ang tawag din sa inyo diyan is prosumer. You are producing energy while consuming, no? Energy from the grid. Then ang provision doon, kinapi lang yung sa Philippine Distribution Code, no? Not limited to single phasing, fault, na-mention ko na yan kanina, no? To in the interest of time, anong oras na ba? Uy, 4 o'clock. Okay. And then also the synchronizing, no? System. So sa distribution utility and then the RE system generator, require yung synchronizing system, no? Ito na yung mga limits sa mga settings. Kailangan compliant kayo dito, no? I-accept din to ng distribution utilities. And then islanding, it's interconnection device. Islanding QE shall disconnect from distribution within 2 seconds, no? Once na detect yung system is down, yung grid is down, at 2 seconds, ma-isolate ka. Okay? So yun yung any detection, no? Na islanding. And then the QE shall provide system against islanding to isolate and block the RE, no? May blocking din, no? At least 10 minutes bago ka magsisynchronize na naman sa grid. So that's the provision or requirement, no? Yun yung kailangan i-comply natin yung with the time, no, na requirement because if not, magkakaproblema talaga, no, yung coordination between the utility and then the DG because of those potential risks. And then for the grounding system, yung mention ko for ungrounded primary, no, there's a potential on over voltage and then potential miscoordination for the distribution side, no. But ang problem nito, medyo mahirap i-deal with the grounded system at the primary because every now and then parang magiging dynamic yung scheme ng distribution system. Imagine if every now and then we don't know, no, kailang mag-maintenance yung DG, then iiba na naman yung fault current, no? Then mag-change tayo ng mga scheme, ng settings na i-coordinate natin with the DG. So ina-encourage yung ungrounded na system to contribute yung to avoid the redistribution of fault current. Although there's a potential over voltage, but we need to have appropriate protection, no? Although we cannot avoid yung potential over voltage, but as much possible ma-isolate natin kaagad during islanding condition. So hindi naman may limits naman, may tolerance naman. So protective control device, no? The QE submit proposal, infuse, any protective and control device shall be coordinated with the DO, no, for approval. Okay? And then ito na yung mga requirements, no? Although it's not stated in the Philippine Distribution Code the protection, no, specific protection requirement, but andoon naman yung specific the protection for the type of generator. Kaya during our introduction, diniscuss natin what are the basic types of generators, no? Kasi na-mention dito yung induction, yung synchronous at saka yung asynchronous. And these are the protection requirement, no? Under net metering rule, no? So above 10 kilowatt, less than 10 kilowatt under over voltage, no? And then the RUCO, no? So yung sabi ko na although your practice, no, there's some practice na communication or transfer tripping yung DG, but maybe it's not practical na magiging may invest ka with the communication transfer tripping for that small generating plant, no, micro. But there's what we call the rate of change of frequency, the ROCOF. The problem with the ROCOF, no, it can address, no, if there's a mismatch of the generator and then the loads, no, kung malaki yung generator mo kung compare with the load during islanding, or mas malaki yung load mo with the generator, makikita yan ng rate of ng ROCOF, rate of change of frequency, no. However, for match talaga, no, nagkataon na pareha yung remaining generator, sustain the loads, no, stable yung ano, yung frequency. Ang problema niyan, ang ROCOF hindi niya makikita, no? There's a limitation. But if given talaga na mas malaki talaga yung potential na mismatch, then ROCOF would be a practical protection. Okay? So ito na yung pinakita lang dito, yung one line diagram, okay, for induction generator. So, yan, na-mention natin. And then for the synchronous generator, ang kahibahan lang niya, mayroon siyang synchronism check, no? But among others, other protection, similar lang yung requirement. Okay? So, yan for the synchronous generator, and then the equivalent one-line diagram. Okay? And then for the interconnection protection requirement for inverters, yun yung mga solar natin, no? Ito, mayroong of course basic, no, over under frequency, over under voltage, and then the rate of change of frequency. Okay, so for the reclosing implementation, if the RE system should immediately disconnect from the distribution system when the system is down. So you know, dapat may detection talaga na pag mawala yung distribution grid, no, automatically si DG mag isolate, no. Then but it's a normal ano isolation, no. Then for the distribution system, automatic reclosing should wait 2 minutes, no, from the time the DU recloses as normalized. So if it's reclosing at 2 minutes po pwede kang papasok, no, magsisynchronize yung DG, no. So it's actually confusing between the islanding and then the reclosing, but it's different, no. This is the it's a reclosing function. So you can wait after 2 minutes, no, nga pwede kang mag-synchronize na naman. And then the voltage level settings, no, the voltage level, or this is the minimum time requirement for I to remain connected at different voltages, different voltage range, no. So based on the percentage. So kailangan yung protection mo is coordinated, no. It's less than the time requirement. Or else magkakaroon ka ng impact with the distribution system. And then the frequency, yung frequency is the same, no? Ito yung mga requirement, time requirement, no, na makapag-sustain siya at still remain connected with the distribution system. And then the testing provision, no? You need to test the reactive power test, the protection test, reconnection timing test, no, blocking test, and synchronizing test, no. And then since we are specific on protection topic, no, so protection test is over under frequency, and then the anti-islanding protection. Okay, so okay. So yun yung mga requirement. Then sa wakas na natapos na rin, no. So my fellow electrical practitioners, after learning this information, you may realize that we have a great responsibilities, no, as licensed electrical practitioners in these great opportunities within the power industry. Kasi napakalaking opportunity talaga with the government program up to 2040. Imagine 50%, no, of the energy sources is coming from renewable energy, no? And then ini-entertain talaga natin yung mga DJ to connect with the distribution system. But we need to balance, no? Check and balance then, and then simulate properly because of those potential risks as mentioned. So ika nga ni Uncle Bob, no, kay Spider-Man, with great power comes great responsibility. the responsibility to deliver a safe and reliable electric service continuously to achieve the ultimate satisfaction of our clients and customer. So always remember that protection is better than correction. So therefore, power system protection is every electrical practitioner's responsibility. So thank you so much for your attention. So back to you, moderator. Thank you.
Thank you so much, Sir ah, Jonathan. Ano? May question lang po tayo dito sa chat box. For any questions din po na ano, you can unmute po. So, from Joji A. Paraiso. Sir, ilang DG megawatt capacity ang required ni ERC sa mga utility companies dito sa Philippines?
Actually, if tama yung take ko, hello? If tama yung take ko sa question, no? Yung requirement, specific, very general sa Pilipinas. But as per Philippine Distribution Code, depende sa classification ng embedded generating plant, no? The large, the up to intermediate, I think, hindi siya, if your substation, no? If you have a substation, distribution substation, dapat hindi ka i-exceed with the minimum load ng substation mo. If not given, so you can consider 25% of the installed capacity ng generator. For example, if you have a 10 megawatt, no, na distribution substation, so hanggang 2.5 megawatt lang yung i-entertain mo, no, as hosting capacity with the distribution system. And also for the specific lines, 30%, no, na mention din doon, yung hosting capacity 30% for the lines, no, feeder. And different din sa sa yung micro and small, 30%, no, with the installed capacity ng generation. So ang point na hindi mo talaga susuplayan, no, yung grid. So kung mayroon kang DG, no, in the low voltage, halimbawa it's a common transformer, no, serving multiple of houses, then hindi po pwede na lahat kayo nakakonect diyan, mayroon kayong sarili nyo na solar. So first come first serve, no, na basis na up to malilimit within the 30%. Then kung ma-island man kayo, no, or I mean kung nagsusupply may excess power ka, excess generation ka, within that thereby na loads mo lang yung ma-serve mo. So kasi if you can imagine, no, na lahat kayo mag-i-exceed with the capacity, ano ba yung mangyayari? Unstable na yung system natin. Parang yung grid, wala nang silbi din yung grid. So that's why i-manage natin. That's why I mentioned, as I mentioned, na if the island, no, islanding scenario, ang tendency talaga, under frequency talaga yung scenario or power quality problem natin dyan, because we cannot allow na we cannot allow yung DG to supply with the grid, no, lalabas yung power to the grid. So I hope na nakuha ko yung question and I answer your question, no.
Medalya ang speaker eh. Medalya.
Okay.
Okay, sir. Thank you po. May next question, sir, from Jason Bersabal. Private utility scenario. Delta primary, Y secondary. What will be the impact on the generation if the system is connected through redundant breakers, series breakers only? Then RE connected to the far end of the feeder, considering protection are all coordinated.
Okay. Hindi ko lang nakuha yung redundant na portion. Can you
Sir
repeat?
Jason, if you can unmute, can we clarify po yung question nyo?
Hello, sir. Good afternoon po.
Yes
Afternoon.
po,
Go
Sir
ahead, sir.
Gibson. Good afternoon. Oo.
Yes, sir. So my question is, we have our utility companies sa Palawan. So, uh, our generator, sir, is connected to a substation without a transformer, only a series of breakers. So we are now have an ongoing project, solar renewable. So mako-connect po siya sa linya by uh, end of this year. So, question ko lang sir, magkakaroon ba ng malaking impact yun sir? Just in case na magkaroon ng sudden shutdown yung aming company.
Okay. So, bago yung DG na yan, is it solar, uh, synchronous generator, ano ba yan, diesel power plant? Or,
Coal power plant sir, coal power plant.
ano ba yung installed
Synchronous sir,
capacity?
synchronous generator.
Anong installed capacity niya, sir?
11 megawatts sir.
11 megawatt. Then, ano yung voltage, uh, nominal voltage ng generator mo po, sir?
4160 sir, 4160.
Then, i-connect siya sa anong utility system voltage.
Sorry sir. The utility is the 4160 sir. So kami,
Okay.
so the
Direkta kayo.
sir, yes sir.
Okay. So direkta pala yung medium voltage kaagad yung generator mo, then
Yes sir.
supplying utilities
Yes
for
sir.
1C. Then kaya walang generator step up transformer. So
Yes sir,
diretso yung
yes.
generation niya. So ano yung question po doon, sir?
So the 4160 sir will be tapped on the substation sir. That's
Yes,
the
yes.
current sir, the existing scenario. So meron kaming renewable energy which is solar power na i-connect this year end doon po sa far end po ng feeder namin. So ang
Mm-hmm.
capacity niya is almost 300 kilowatt.
Mm-hmm.
Tanong ko lang sir kung ano yung magiging impact niya just in case na magkaroon ng sudden shutdown for both first scenario is kung yung RE yung mag-shutdown or yung generation side yung mag-shutdown.
Okay. So yun nga, sir. If dalawang scenario, no? If yung RA ang mag-shutdown, walang significant impact, no, with the generator. If the generator has yung tatawag na automatic generator control, na yung capacity niya, no, with the solar, of course, at normal condition, sharing of loads with the RE, the solar, no, for example 300 megawatt versus the 10 megawatt is how many percent lang yun, no? Parang iti-take over ng synchronous generator mo when mag-out yung RE mo, then titik over niya yung load na 300 megawatt if mayroon pang siyang enough capacity, no? If not, yung impact niya, uh, it's a slight na it's not that significant yung impact, no, since it's a 300 megawatt. Siguro may small change lang with the frequency in the meantime. And then kung hindi masyadong sensitive lang yung protection mo, then may enough time na i-take over pa ng kung mayroon pang remaining capacity yung generator mo, then mako-compensate niya, no, making the system stable yung frequency, and then the under voltage. Okay, so yun yung scenario pag mag-out si RE because it's a losing generation. Then in the meantime, magkakause siya ng momentary overload yung generator mo remaining, but it's not that significant, no, since it's 300 megawatt. But on the ano naman natin, no, baliktaran naman natin. Halimbawa, si generator mo, yung for 160 or the 10 megawatt na generator mawawala. Yun, may requirement, no, si RE na talagang mag-isolate siya, no, at 2 seconds. So hopefully compliant siya, no, na mag-isolate siya at 2 seconds. to avoid islanding with the loads, existing loads. But if not, ma-overload yung momentary, ma-overload yun. I'm sure mayroon namang overload protection na naman yung solar. So, but it's a secondary protection. But hopefully compliance with siya with the primary protection yung islanding. So, yun yung yun yung magiging possible impact niya.
Thank you, sir. Anyone? If may questions pa po kayo? Sir Jaime, sige po.
Okay. Better na, better. Okay.
Okay na po.
Yes,
May
yes po.
ang katanungan ko lang po, doon po tayo sa high voltage na renewable energy, for example sa solar or wind farm.
Yes po, sir.
Sa high voltage po tayo. Meron po bang time frame para sa frequency? Dahil sa solar po, alam natin na nag-variable siya. Dahil
Yes po.
kung merong yung sikat ng araw, nagkakaroon ng effect po yun. No? Meron ho bang time frame sa frequency, over voltage and under voltage para mag-blackout?
What
Sa
do you mean
system.
what do you mean by blackout?
Mag-trip yung system na hindi siya pumasok sa grid.
Yung
Solar.
wind, yung farm? Oo. Opo.
Let's say, for example, solar. Naka-connect, naka-ano siya sa nakaparallel din siya sa normal na power plant na system sa transmission line o sa substation, nakapasok sa substation. Meron po bang time frame kung nagkaroon ng under voltage or over voltage para mag-trip siya or mag-blackout? May requirement po ba ito?
Actually, sir, sa if tama ba yung take ko sa nyo is kung compliant ba yung solar, no? Of course, medyo variable man siya, di ba?
Apo.
So, yung variation niya medyo depende talaga sa sikat ng araw. So, if ako per analysis lang, I don't have I don't have talaga personal knowledge ng operation ng solar, no? Ng talagang ano ba yung parang problem nila, no, with the operation. But my perspective, since it's a variable, no, yung load, and then of course mayroon ding yung while yung load mo is not really coordinated din, no, yung papasok since variable din yung load mo, considering the load is constant and then hindi nag-respond or walang spinning reserve, no, parang ganyan, or walang yun yung term, no, spinning reserve, and then may tendency na mababa talaga yung load, no, yung power, no, yung generating power from the solar, magka-experience talaga, no, yung system with under frequency kasi imagine without any available sources generator with a constant load, nawalan siya for that specific duration because the 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 generating power, no, is very dependent on the solar. Possible na bababa siya. So yung system ngayon magkakaroon ng under frequency. So kung properly managed lang yung system, no, halimbawa sa amin sa distribution company, nag-implement kami na tinatawag na automatic load drop, no. There's a corresponding i-nominate mo yung feeder, yung load na at this in the absence of this specific loads, since magkakos siya ng under frequency sa system, then ang settings nung nominate, no, na feeder, for example sa substation, siya yung mauna kasi may scheme 1, scheme 2 yan.
Opo.
Until nga ano talaga yung frequency mo. Automatic i-load niya, hindi the entire, no, hindi
Mhm.
talaga yung blackout talaga because nawala ka, but pinipili yung equivalent na load to make the system stable. So to answer
Mhm.
your question, sir, kung mayroong magba-brand out, possible mayroon talaga because you
Ako
need
nga po.
to stabilize the system, atin na talaga natin yung normal frequency. Hopefully
Opo, yun nga.
nasagot, sir.
Yun nga po na dahil nagkakaroon po tayo ng sudden change ng weather, bumababa rin yung bigay ng frequency, nagkakaroon po ng effect sa
Yes, yes.
frequency. So,
Yeah, oo.
instead yung baba ng frequency, papasok sa isang, nakakonekta siya sa, let's say, sa, wag na tayo lumayo, katulad nung nag-question before me yung una, na meron silang generator, tapos merong solar. Let's say na nakakonekta pareho. Yung pong nagkaroon ng nagkaroon ng irradiance sa solar, magkakaroon effect sa frequency, hindi siya magma-match ngayon sa frequency ng generator ng company. Ngayon, pag nawala yung nag-under frequency siya, yung may oras po ba para mag-trip na po yung hindi na siya pumasok
Yes
dahil
po,
under
sir.
frequency? Mga ilan po ang
Yung
mayroon po
pinakita ko kanina, ano ko dito sa frequency. May frequency, tinatawag na frequency variation. Ang frequency, uh, uh, makita ko dito. Okay. So, for the frequency, yan ako, sir. Ito. So, minimum time requirement for RE to remain connected at different frequency ranges. So, its continuous operation between the 61.8, no, in between 58.2. So, pwede pa yan. But above or below, no, kasi under frequency, below 58.2, no, below 5 minutes, no, possible
Okay.
pag exceed siya with the 5 minutes, talaga hindi na yan tolerable. So
Uh,
dapat yung settings ng protection mo diyan, siya yung yun yung settings na mag-isolate ka.
Ilalockout niya na.
Correct po. Pero
So,
some application, ano yan, very conservative din yung scheme, hindi ganito katagal, no? Sa amin, mga up to 100 ms pa nga yung mga isolation, to remain the system stable.
Meron pa akong isang katanungan. May nabasa po ako. Medyo lang sa akin. Ganon din po sa high voltage. Alam po natin na yung frequency sa mga normal na power plant like nuclear, like coal power plant, yung frequency problem na-suppress na po yan, no? Na-suppress na yan talagang po 60, talagang lalabas niya 60. Ngayon sa renewable energy naman, tulad nga po na napag-usapan natin sa solar, dahil sa problem ng irradiance, nagkakaroon po ng problema sa frequency, no? Madalas po mangyayari yan. Ngayon, sa dami na nagtatayo na namumuhunan na maglagay ng solar power, naipasok niya sa grid, marami na ngayon, madalas magkaroon ng irradiance, nagkakaroon sila ng problema in future, magkakaroon po ng problema.
Hello?
Ngayon, ang ginagawa raw, yung transmission line, alam natin, solar DC, transmission line, high voltage DC, patatakbuhin nila. tatakbuhin nila high voltage DC, pupunta sa substation, tapos i-inverter, magiging AC na po. Pero may cost pa rin, nagkakaroon pa rin ng problema, yun nga ang problema sa frequency. Meron silang para ma-suppress naman daw yung frequency, yung problema sa frequency, may dalawang bagay daw silang inaano, yung notch filter tsaka band end. Familiar po ba kayo roon sa notch filter tsaka band end?
Sorry po sir. Hindi po ako familiar with the
I see. Anyway, disregard nyo na po yung ano. Dahil gusto ko lang pa-elaborate ko ano yung nagiging ano nila. Yung notch filter. Notch filter tsaka band
Sir,
end.
try nating notch filter band end. Sige, try ko ring research sir, and then hopefully ano tayo or baka ma-share mo rin sa akin. So, interested din ako sa ano mo, sa question mo.
Dahil medyo nabasa ko yan, medyo actually galing ako sa sa Saudi Electricity, retired na ako sa project management ng substation, high voltage substation, tsaka extra high voltage. Kaya ngayon, ito hindi ko na inaabot. Yung hindi ko na nag-retire na ako, yung nagpasukan na yung malalaking renewable energy doon. Anyway,
magkaroon tayo ng ganyan sa Pilipinas.
Pero substation doon puro indoor, puro GIS.
Oo nga.
Sige po. Maraming salamat po.
Thank you po sa tanong po. Okay.
Opo.
Thank you po, Sir Jaime. Thank you, Sir. Sir Jeff, go ahead po. Naka-raise ng hand po kayo.
Ay, thank you, Engineer Dan. Ano lang naman to para lang ma-recognize din natin sa ating suking speaker, si Sir Jonathan. Lagi natin speaker yan sa Thursday Delight, At saka with with this topics talaga regarding renewable energy talaga, marami talagang aside sa mga government efforts din para encourage yung ibang mga developers for RE, nanganak din talaga yung mga technical topics regarding renewable energy. So yung pong mga request po natin, halimbawa na ibang mga topics, sige, you can also send us those topics then, and then we'll try to find ways din po para po ma-deliver din po natin itong mga topics ito sa ating mga sa ating mga audience din po at saka practitioners. So itong topic na to na discuss ni Sir Jonathan is napakaganda, not only for those practitioners, but pwede din sa mga students din at saka sa mga iba pang mga nasa field of electrical engineering. So ito po, may nakikita kasi ako sa chat box na mga nagre-request ng mga topics about regarding the renewable energy. So yun, we'll try our best din po para po ma-address natin itong mga topics na to in the near future. Yun po. Sir Jonathan, thank you po very much. Thank you po sa pagpapaunlak sa amin.
Thank you po, sir. Thank you po, sir. Until next time po.
Yes. Oh, sana po, every time, sana po. Libre.
Sige po, pag nag-time tayo, sir. Thank you po.
Thank you very much. Engineer Dan, thank you.
Sir Jeff, okay lang, Sir Jeff. Kayo po ng certificate natin.
Sige, sure.
Sige po. Share ko lang, sir, to award our certificate
Sure.
of appreciation po.
Sure.
Yan, sir. Wait. No. Yan. Sige po, Sir Jeff.
Okay. For the end time, bibigyan namin to kay Sir Jonathan, pero for everybody's information. So, the Institute of Integrated Electrical Engineers of the Philippines, Northern Laguna Chapter, City of Santa Rosa, City of Binyan, City of San Pedro, IIEE Best Chapter Hall of Famer, gives the certificate of appreciation In recognition to Engineer Jonathan J. Medalla, PEE, AER, ACPE, for sharing this technical expertise on the topic entitled Interconnection Protection for Distributed Generation and Renewable Energy during the Thursday Delight webinar given this 31st of October 2024. Signed by yours truly, Anthony Jefferson S. Atienza, REE, Vice President for Technical Affairs. Signed by Reginald M. Castillo, PEE, President of NLC. Syempre, ang ating nasa audience din po, si Pres Rodel, ang ating pong webinar proponent at co-host ng ating webinar, Delito V. Manalo, PEE, at ang ating National Vice President for External Affairs at ang ating host, si Miss Esperanza A. Collado, REE, MMEM. So thank you very much, Sir Jonathan, for having our webinar again. Thank you.